Think about last year, not a specific moment, the whole thing. January to December, 12 months, 365 days, somewhere around 8,700 hours of your life. Now be honest, how much of it do you actually remember? Not the holidays, not your birthday. Those don't count. Your brain was expecting those. Think about the ordinary weeks, the Tuesdays, the Thursday afternoons, the Sunday evenings before Monday hit you again. Try to pull up a single image from a random Wednesday in March. Nothing. There is nothing there. And here is the part that should make your stomach drop. It is not because those days were unimportant. It is because your brain never recorded them. They happened. You were breathing, your heart was beating. But neurologically, according to your own memory, those days did not exist. They were deleted, not by time, by your own brain. And the worst part, nobody warned you this was happening. Nobody sat you down at 18 or 25 or 30 and said, listen carefully. Your brain is going to start erasing your life. Year by year, it will record less and less until entire decades feel like a weekend. And the system that educated you, the same system that told you to sit down, memorize, repeat, specialize, optimize, and comply, that system is the reason it is happening this fast. A physicist named Richard Feynman figured this out. Not in a lab, not through some elegant equation. He figured it out by living a life so aggressively different from what the system prescribed that he accidentally became the living proof of a neuroscience discovery that would not be published until 30 years after his death. And what he proved, what the science now confirms, is not just disturbing. It is a direct accusation against everything you were taught about how to live. Your time is not speeding up because you are getting older. Your time is speeding up because you were trained to let it. To understand how they did this to you, we need to start with what is actually happening inside your skull right now, at this very moment, as you are hearing these words. In 2019, Adrian Bejan, a professor of mechanical engineering at Duke University, published a paper in the European Review that finally put hard physics behind something every human over 30 already feels. The paper was called Why the Days Seem Shorter as We Get Older, and the answer was not philosophical. It was mechanical. Here is what Bejan found. Your brain does not measure time with a clock. It measures time through images. Every moment of your conscious experience is built from a rapid sequence of mental snapshots, visual frames captured by your eyes, processed through your neural pathways, and assembled into what you experience as now. When you were a child, those pathways were short, clean, and fast. Signals raced from your eyes to your cortex with almost no resistance. Your brain was capturing reality in something close to slow motion. Thousands of mental frames flooding in per day. Every hour was dense with information. Every afternoon was an ocean. That is not a metaphor. Bejan measured it. Infant eyes make rapid movements. Scientists call them saccades, far more frequently than adult eyes. A baby's visual system is scanning the world constantly. Pulling in massive amounts of data, encoding everything because everything is new. The result is that a single day for a 5-year-old contains more processed mental images than a single day for a 50-year-old. Not slightly more, dramatically more. And here is the mechanism that no one told you about. As you age, two things happen simultaneously inside your brain. First, your neural networks grow more complex, more connections, longer pathways. Signals have to travel farther to reach the same destination. This means processing slows down. Second, and this is the part that should frighten you, those pathways start to degrade. The nerves accumulate physical damage over time. Think of it like old wiring in a house. More resistance, weaker signal, slower transmission. The combined result is brutal. Your brain processes fewer images per unit of time. Your eyes move more slowly. Your saccade velocity drops. And because your brain measures time by the number of new images it processes, fewer images means less perceived time. The clock on the wall still reads 24 hours, but your brain experienced maybe 12 or 8 or 4. The rest was not lived, it was skipped. This is not a theory about feelings, this is physics. This is measurable signal degradation in biological hardware, and it means that right now, today, your brain is capturing a fraction of the reality it captured when you were 10 years old. You are literally experiencing less life per hour than you used to. And every year, the fraction gets smaller. But Bayesian's research only explains the hardware, the wiring, the signal speed. It does not explain why some people seem to age out of time so much faster than others. It does not explain why your last 5 years feel like 1 year, while someone else's last 5 years feel like 15. For that, we need a different piece of the puzzle. And we need to go back to 1951, to a classroom in Rio de Janeiro, and to a physicist who was about to expose something so ugly about education that a government official would call it a cancer. Richard Feynman arrived in Brazil to teach advanced physics at the University of Rio. The classroom overlooked Guanabara Bay. Sunlight bounced off the water every single day. And every single day, Feynman noticed something that ate at him. His students were brilliant at reciting. You could ask them about Brewster's angle, the specific angle at which light reflecting off a surface becomes perfectly polarized, and they would rattle off the textbook definition without pausing for breath. Perfect recall, word for word, flawless. Then Feynman would point at the window, at the bay, at the actual sunlight reflecting off the actual water right in front of their actual eyes. And he would ask them to apply what they just said, to look at real light hitting a real surface. Blank stares, nothing, dead silence. As he later wrote in, "Surely you're joking, Mr. Feynman," everything was entirely memorized, yet nothing had been translated into meaningful words. The students could access the information if you used the exact keywords from the textbook. But if you said, "Look at the water," nothing happened. They had no mental file under "look at the water," only under light reflected from a medium with an index. He sat in on an engineering lecture. The professor dictated so slowly that students copied every word into their notebooks. One student proudly showed Feynman an upcoming exam question and its answer, memorized verbatim. The student would pass. The student understood nothing. At the end of his stay, Feynman gave a speech to professors and government officials. He laid it out directly. The system was not educating anyone. It was training human recording devices. And the head of science education stood up after and said, and this is documented, "I came here knowing we have some sickness in our system of education. What I have learned is that we have a cancer." Then came the gut punch. And the two students who had actually performed well in Feynman's class stood up. One had been educated in Germany. The other had a similar story. And the one Brazilian-educated Professor Feynman had praised, he had taught himself during the war, when all the professors had left. Nobody who had been fully trained by the system had succeeded. The failure rate was 100%. Now, why does this matter for time? Because what Feynman witnessed in Brazil was not just an education failure. It was the exact neurological mechanism that makes your years disappear. And here is the connection that nobody makes. When you memorize without understanding, when you repeat without processing, when you learn to pattern match instead of actually seeing, you are training your brain to skip reality. You are building the neural equivalent of a highway bypass around actual experience. Information comes in, gets routed to the already mapped folder, and is never encoded as a new memory. This is what neuroscientists call neural adaptation. Your brain is designed to ignore what it has already mapped. It conserves energy by refusing to process what it considers redundant. A child has almost nothing mapped, so almost everything gets processed. An adult who has spent 20 years in the same career, the same routines, the same patterns of thought, almost everything is mapped, almost nothing gets through. And the system accelerates this. 12 years of school, 4 years of college, a career built on specialization. Every step is the same instruction. Memorize the pattern, repeat the pattern, optimize the pattern. Do not deviate from the pattern. You are being trained, systematically, to build thicker and thicker bypass highways around actual experience. The result? Your brain stops recording, and when your brain stops recording, time collapses. Not because the clock changes, because there is nothing left in your memory to give those hours any weight. A study by psychologists Mark Whitman and Sandra Lenhoff surveyed 499 people ranging from age 14 to 94. When participants over 40 were asked to reflect on their lives, they consistently reported the same pattern. Time moved slowly in childhood, then accelerated steadily from the teenage years onward, gaining speed with each passing decade. And the math behind this is even more disturbing. In 1877, And a French philosopher named Paul Janet proposed that each year feels shorter because it becomes a smaller fraction of your total life. At age 5, 1 year is 20% of everything you have ever experienced. At 50, it is 2%. This alone would be bad enough. But a mathematician named Robert Lemlich took it further. He built a more precise model and found that time perception is proportional to the square root of your real age. Under his framework, a 55-year-old experiences time, passing roughly 2.25 times faster than an 11-year-old, and the following periods of life feel subjectively equal in length: 0 to 1, 1 to 4, 4 to 9, 9 to 16, 16 to 25, 25 to 36, 36 to 49, 49 to 64, 64 to 81. Read that list again slowly, because hidden inside it is a truth so uncomfortable that you will want to argue with it. By the time you reach 25 years old, roughly half of your subjective life, the life you actually feel and remember, is already over. You could live another 60 years, but those 60 years will feel like less than the 25 you already burned through. Not because those years are worth less, but because your brain will record less and less of them. And now, ask yourself, what were you taught to do between ages 5 and 25? Sit in a classroom, memorize, repeat, follow the pattern, do not deviate, do not question, do not waste time playing. They spent the richest perceptual years of your life training you to stop perceiving. But there was one man who broke this. And he did not break it with meditation or philosophy or some self-help morning routine. He broke it with a wobbling plate in a cafeteria. 1946, Cornell University. Richard Feynman is destroyed. His wife Arlene is dead. Tuberculosis took her in 1945. She was 25. He had been with her since high school. He had married her against his family's wishes, brought her to a sanatorium near Los Alamos while he built the atomic bomb, visited her every week, and watched her fade. After she died, he drove back to the lab. He reportedly did not cry until weeks later, when he passed a dress shop and thought about how Arlene would have looked in one of the dresses in the window. Now he is at Cornell. Physics has become work, pressure, expectation. And he turns down an offer from the Institute for Advanced Study in Princeton, the most prestigious intellectual institution on Earth, because he is convinced he is burned out and will never produce anything significant again. And then he makes a decision that, without knowing it, attacks the very mechanism of time acceleration that Bejan would identify 70 years later. As he writes in Surely You're Joking, I'm going to play with physics whenever I want to, without worrying about any importance whatsoever. Play, not work, not optimize, not specialize. Play. Within 1 week, he is in the Cornell cafeteria. Someone throws a plate into the air. It wobbles, and where every other person in that room sees a plate, Feynman sees the red Cornell medallion spinning faster than the wobble. He has no reason to care. No professor assigned this. You see, no grant depends on it. No exam will test it. But his brain locks onto the detail. He sits down and calculates the motion, discovers it is a 2-to-1 ratio. He runs to Hans Bethe, a Nobel laureate, and shows him. Bethe asks the question the system always asks. That's pretty interesting, but what's the importance of it? Why are you doing it? And Feynman gives the answer that the entire education system fears. There's no importance whatsoever. I'm just doing it for the fun of it. That wobbling plate led to equations of wobbles. Those led to electron orbital motion in relativity. That led to the Dirac equation in electrodynamics. That led to quantum electrodynamics. That led to the 1965 Nobel Prize in Physics. As Feynman described it, it was effortless. It was easy to play with these things. It was like uncorking a bottle. Everything flowed out effortlessly. But here is what nobody talks about. What Feynman did with that plate was not just physics. It was a neurological act of rebellion against time itself. Think about what happened in his brain at that moment. He had been stuck in routine, grief, obligation, pressure, repetition. His brain was in full neural adaptation mode, processing almost nothing new. Time was collapsing for him, just as it collapses for everyone. Then he forced himself to notice something useless, something playful, something no one else in that cafeteria cared about. And in that instant, his brain switched back on. New data, new processing, new images encoded, new connections formed. The slow-motion camera started capturing frames again. He did not just save his career with that plate. He expanded his experience of time itself. And this was not a one-time accident. Feynman built his entire life around this principle, though he probably never called it that. He had a method, documented by mathematician Giancarlo Rota, who recalled Feynman's advice. Keep a dozen of your favorite problems constantly present in your mind. They will lay dormant most of the time. But every time you hear something new, a trick, a result, a random observation, test it against your 12 problems. This is the opposite of what the system teaches. The system says, solve the problem, submit the answer, close the file, move on. Feynman says, never close the file. Keep 12 of them open, forever, because when your brain is always cross-referencing new inputs against old problems, nothing is routine. Every conversation is a potential key. Every observation is a possible connection. Your brain cannot go on autopilot because it is always checking. Does this new thing connect to problem number 3? Problem number 7? Problem number 11? This is forced novelty. Manufactured neurological youth. And it is available to anyone, not because it requires genius, but because it requires the one thing the system trained out of you, the willingness to stay confused, to keep questions open, to not resolve everything into a neat, memorized answer. Feynman took this even further. He did not just keep problems open, he deliberately made himself incompetent, over and over again. He learned bongo drums and played in Brazilian carnival, badly at first, then passionately. He picked up drawing and sketched until he could sell his artwork. So he cracked safes at Los Alamos to prove the security was flawed. He wandered into a biology lab at Caltech and spent a year studying viruses, a field where he had 0 credentials. He studied Mayan hieroglyphics. He learned enough Chinese calligraphy to write to his sister just to prove he could. This was not a man collecting hobbies. Look at the pattern. Every single one of these activities put him back at the bottom, back to beginner, back to the state where nothing is mapped, everything is new, and the brain has no choice but to process every single detail. And this is the part that should hit you personally, because your brain processes dramatically more information when you are a beginner at something than when you are an expert. Experts have mapped their domain. Their brains skip over familiar patterns to conserve energy. A surgeon on her 5,000th operation is not processing the same density of experience as she did on her first. An accountant on his 2,000th tax return is not neurologically present the way he was on day 1. The experience still happens. The clock still ticks. But the brain does not record it, and time vanishes. Feynman refused to let expertise become a neurological prison. Every time his brain started mapping a domain, getting comfortable, getting efficient, getting fast, he jumped into something where he was completely useless, and his brain woke back up, and his time expanded. Meanwhile, and this is the modern accusation you need to hear, every piece of career advice you have ever received pushes you in the exact opposite direction. Specialize, find your niche, optimize your workflow, build habits. It's automate the repetitive, streamline. Every single one of these instructions is telling your brain, map it, skip it, stop recording it. Every single one is accelerating your subjective death. And it gets worse, because the systems you use daily now do this at a scale Feynman could never have imagined. Your phone's algorithm serves you the same category of content, reinforcing the same neural pathways, training the same adaptation. Your remote work setup puts you in the same room, same chair, same screen, same posture, day after day after day. Your optimized morning routine, the one some productivity influencer told you would change your life, is neurologically identical to putting your brain in a coma. Same coffee, same order, same steps, same mapped highway. 0 new processing. You are not living a streamlined life. You are living a shrinking one. And this brings us to the final piece, the moment that ties all of this together and leaves you with something you will not be able to forget. February 15th, 1988. Richard Feynman is dying. Kidney failure, a rare form of cancer, has been eating at him for years. He is 69 years old. He has won the Nobel Prize. He has rebuilt quantum electrodynamics. He has exposed the Challenger disaster. He has taught a generation of physicists. He has played bongos in Rio. He has cracked safes and painted nudes and decoded hieroglyphics and written letters to a dead wife that would not be found until after his own death. And his last words, documented, verified, repeated by everyone who was in that room. His last words were these: "I'd hate to die twice. It's so boring. Not, I am afraid. Oh, not, I am in pain. Not, I wish I had more time. Boring." His last enemy was boredom, and now you understand why. Because boredom is the neurological signature of a brain that has stopped processing new information. A brain in boredom is a brain in full neural adaptation. Nothing new coming in, nothing being recorded, no frames being captured. In Bayesian's framework, a bored brain is a brain where subjective time has essentially stopped. You are breathing. Your heart is beating. But you are not, in any neurological sense, experiencing life. Feynman understood this, maybe not in the language of neuroscience, but in the language of a life lived so aggressively against routine that his brain never stopped recording. He did not fear death. He feared the thing that was already happening to everyone around him, the slow, invisible, as system-approved shutdown of actual experience. And here is the vindication you need to carry out of this. It was never about intelligence. Feynman's IQ was measured at 125, respectable, not extraordinary. Plenty of people with higher IQs have lived lives so routine that they cannot distinguish one decade from the next. The difference was never processing power, it was processing intention. Feynman deliberately, relentlessly, systematically forced his brain to stay in the mode where time moves slowly, where every day is dense, where the camera captures everything. And if your last 10 years feel like 2, that is not because you are getting old. That is not because time just works that way. That is because the system spent your first 25 years, the most perceptually rich years of your life, training you to stop noticing, to memorize instead of see, to optimize instead of explore, to specialize instead of begin, to answer instead of question. The mechanism is real. The neuroscience confirms it. The physics explains it. And a Nobel Prize-winning physicist proved with his entire life that the mechanism is reversible, not through meditation, not through journaling, not through some app that reminds you to be grateful, through the brutal, uncomfortable, ego-destroying act of making yourself a beginner again, of keeping questions open that the system told you to close, of noticing the wobble in a plate that everyone else ignores. Your brain is not broken. It was trained. And what was trained can be untrained, but there is a cost. The cost is that everything the system told you to value, efficiency, specialization, optimization, routine mastery, is the very thing that is stealing your years. To get your time back, you have to be willing to be bad at something again, to feel stupid, to waste an afternoon on something that has no importance whatsoever. Feynman did not call it a method. He did not call it a technique. He called it what every child calls it before the system beats it out of them. He called it play, and the science now tells us that play is not a luxury. It is not a reward you earn after productivity. Play, genuine, ego-free, purposeless engagement with something new, is the only known mechanism for reversing the neurological process that makes your life feel like it is disappearing. It's the years you lost are gone. The neuroscience is clear on that. But the years you have left, those are still a fight. And now you know what you are fighting. Not time, not aging, not some inevitable decline. You are fighting the system that taught your brain to sleep with its eyes open. And that same logic, the logic of play over productivity, of curiosity over compliance, exposes another lie you were told. One that affects not just how you experience time, but how you make every important decision of your life. And it explains why the smartest people you know keep making the worst choices. But that is a different deception, for a different day.